Good morning, everyone, and welcome to Numericals Studio. Today, again, we brought a very important and the important concept of motion in one dimension. It's all about the position time graph. Friends, as you all know, that to define a motion, we need to understand that whenever a body changes position with respect to time, that means what I'm saying that if the position of body is changing with respect to time, if x is function of t, that means if x is changing, then only we say the uh, body is in motion. So this is another problem from that great book Erodo, in which the author basically try to understand that whether you get the concept of xt graph well or not. So let's read the problem and understand that what kind of concept that are involved in this problem and how to go about it. So the problem states a point moves rectilinearly. That means this word is called rectilinear. This word means straight line, in a straight line. Okay, in a straight line. So this is an example of motion in one dimension. So whenever I'm saying the motion in one dimension, it's involved that particle is either going towards x-axis or towards y-axis or towards z-axis. Okay, if we just try to represent the motion in terms of coordinate system. Okay, so again, going back to the problem, a point moves rectilinearly in one direction. The distance traveled by the point as a function of time using the plot. So this is the plot of s versus t. Okay, so whenever I am saying that the motion in one dimension, that means we can say that my velocity and my speed at any particular time would be like instantaneous velocity, magnitude of instantaneous velocity and speed would be same, because it is just going in one direction. Okay, and on the similar concept, we have studied one more problem in our previous video. Okay, if you just want to understand the concept here, application of this concept in more deeper way, you can refer that problem also. But for the time being, let's try to focus on this problem. So we need to find out the average velocity of the point during the time of motion. Second, maximum velocity. And third, the time at which the instantaneous velocity is equal to the average velocity. Okay, so what are the concepts are involved? So whenever a one dimensional motion is involved, I already told you that it will involve only one axis for the coordinate system. Okay, now whenever you are talking about the x and t, that means if the position is a function of time, that means with time if position is changing, that means body is in motion. Okay, so if body is in motion, that means we need to draw an xt graph. Now see, this is an example of two xt graph which I have drawn over here, this and this. Okay, in xt graph, in this particular graph, you can see that motion is started from t equal to 0 to some time t2. Okay, so if I just want to find out what is the average velocity, that means x equal to what? What is x equal to? Distance equal to, it can be the simpler formula vt. Okay, and v equal to what? Velocity equal to what? Distance by time. So what is distance by time? If we just see that this, if I just try to find out the slope of this particular graph, tan theta, then tan theta can be written as b, suppose this is p, bp by PA. So BP will nothing but the difference in the position. So x2 minus x1, and PA is nothing but the difference in time. So that means tan theta is nothing but the slope of the secant of this graph. So slope of the secant of this graph of xt graph basically gives you what? Basically gives you the average velocity. So this particular tan theta can be written as average velocity or the mean velocity of xt graph. But if we just try to take all these 2 points so closer that they meet at a point, then this particular secant will be a tangent. Okay. Now this tangent, if we just extend this tangent, then this will cut the x-axis line or the timeline. Then this tan theta will be nothing but the instantaneous velocity. Okay. Clear? So in all the xt graph, we need to understand that the slope of xt graph basically give you the velocity, and if there is a slope of secant, it will give you the average velocity. Now whenever the maximum velocity is involved, that means you have to find out the point at which we are getting the maximum slope. So if I am saying that instantaneous velocity is equal to average velocity, that means I could say that at a particular point the velocity is either constant, because if the velocity will be constant, in that case the slope will be constant, and in that case the slope of secant will be the slope of tangent. So I hope I have clear the concept before you, that what kind of things that are needed to solve this problem. So let us try to solve this problem. Okay, I'm just expecting you to give me the send me the answer, or solve at your end. Pause the video, solve at your end after getting this concept, and try to match with the solutions of the Erodo. It is available online also, or if you have got any hard copy, you can see the answers. So average velocity during the time of motion. So this is the time of motion. See, this is the entire time of motion. But here you can see from this point to this point, the displacement is position is not changing. There is no change in position. If there is no change in position, that means there is no slope. If there is no slope, that means the body is at rest. So at this point, body is at rest. Body is at rest. Whatever particle that is moving, after coming to this 20 second, it is almost at rest. So the entire time of motion is nothing but 0 to 20. So what do you need to find out? The average velocity. We just have to draw a secant between 0 to 20. Pardon me. Okay. Sorry, it is not touching. So this is the slope. Okay. This tan theta can be written as like from here to here. Okay. So this can be written as like this is at suppose at 2, that means 2 meter, and this is almost 10, uh, 10, 11, 12, 13, 14, 15, 10, 1, 2, 3, 4, 5. So 5 equal to 10, so 1 equal to 2, so 2, 3, 4, 6. So this is 16. Okay. So this is with 2 by 16, that means 1 by 4. Okay. This is the meter per second is the average velocity. Okay. The maximum velocity. Again, when I'm just talking about the maximum velocity, what you need to see? You need to see the maximum slope of this graph. So see, at this point, if I just try to draw a tangent, then this will be like this. And at this point, the slope is maximum. It appears to be maximum at least. Okay. So this is the thing where we need to find out. So we can take this and this and this and this. Okay. So if I just mention this is PQR, then you can write that average velocity, the maximum velocity will be tan theta. It can be written as PQ by RQ. Okay. You can calculate it. Now you need to find out the time at which the instantaneous velocity is equal to the mean velocity over the first t2 seconds. Okay, so that means we need to find out the slope of secant is equal to slope of tangent. So if I just draw a tangent over P, suppose I'm just drawing a tangent over P, then this tangent will straight away cut, it passes through the origin. So this is the point, this is the point, this is the time, this is the time at which the slope of secant is equal to slope of tangent. So we can say this is 16. Okay, this is the 16 second at which the velocity, instantaneous velocity, is equal to the mean velocity. So friends, this is all about the solution of this particular problem from the Erodo. I hope that I have left no concept untouched and of one dimension motion. And at the same time, now you are in a position to understand that what you could do if a xt graph is given to you. Whenever xt graph is given to you, you should look that slope of that graph. The slope of that graph is going to give you about the velocities, okay, or the speed. If it is a one dimension, we just interchangeably use this word. Okay, now based on this particular problem, I have tried to tweak it, and I have given a challenge problem for you. Okay, so the position, velocity and acceleration of the particle, leave the acceleration for the moment. The position, velocity and acceleration of particle with a constant acceleration can be represented by. So if you know the acceleration, you can solve it. If you don't know the acceleration, then wait for our next video, because in by next video we'll be introducing a concept on acceleration also. Friends, with this we are at the end of our topic of the day. I hope you are finding Numerical Studio beneficial for your preparation, and at the same time I request all of my subscriber, the little subscriber, whatever we have managed to gather in this period of time, I just request them that please share it to the friends, who are basically preparing for the same examination, similar examinations, and have the similar ambitions. And I'm just promising you that you will not find physics any longer a nightmare for you. Try to make it very easy, and try to bring all the concept on your table. And I hope that it will not only help you to be a pro in physics, but at the same time can fetch you good ranks. Friends, one additional announcement is here that we are planning to start a chapter-wise videos from our next session. So we'll be starting from motion in one dimension, and we'll be touching all the aspects, and similarly we'll go on. So let me know that what you think about this idea of ours, and if you think that this idea is this idea is workable, then in that case we'll be bringing the videos. Okay. At the same time, I have also got few suggestions from the students that we should bring more challenging problem from the other books like Krotovs and etc. So I'll be presenting some solutions from that book also, and try to cover the similar other books which presents you a good sets of physics problems, so that it can help you in the IIT advanced examinations. So thank you with that. With this, I just end the topic of the day, and have a good day.